Hello everyone. So, this is lecture 1 for the module 1 for the course computer programming, and in today's lecture I am going to talk about the computers and the programming languages types and the problem solving using the computers. How to solve the problems, what are the basic steps that we are going to discuss in today's lecture. So, first we will talk about the computers and the programming. What are the computer basically, and how the programming we do on the computers. Second is the programming language types, and third topic which I will going to talk in this today's lecture is the problem solving. So, as we know that computer is basically a computing device. So, what does it mean by the computing device? Computing device means it basically facilitate the computation of anything that is computable. So, what does it mean by the computable? Means we can solve, let us say we can solve with the help of hand, means I can derive a solution without taking any help from any machine. If it is solvable by hand, that means it should be solvable by the any machine as well. Now, the question is, can we store all the possible computations? Let us say I have to compute the area of a rectangle. So, is it possible to any possible combination of length and breadth, and that I can store in the computer? It is possible? Certainly answer is no. So, for that what I have to do? What should be the facility should be available in the computer? So, in that case how? So, essentially what we are trying to figure out, how the computers performs the computations. It is not like that all values, the multiplication of the length and breadth of all possible combinations, we can use it, we can store it all possible combination. That is not an efficient solution. So, what is the efficient solution? That computer should provide some facility such that in terms of some instructions I can write, I can instruct my computer, and then the whatever value I will provide, accordingly it can produce the result. So, for doing such computations, computer having the facility to execute basic computation steps, and these basic computation steps are called as an instruction set. It is a collection of these basic steps, and that collection is called as an instruction set. Now, I have an instruction set for a particular computer is on which I am working, it is available with me. I know that instruction set. Now, how to use that instruction set to solve my problems? So, the next question is, what is programming as such? Means to solve the problem with the help of the computer means what I am doing? I am trying to program my computer. So, programming means instructing a computer to execute a sequence of steps of your problem. Here each step is representing a built-in instruction in the instruction set of that computer, and this process of instructing a computer is called as a programming. And what will be the outcome of this? The outcome will be the program for which you are solving the problem. Now, the different computer, every computer have its own different or own instruction set. What does it mean? Instruction set, each, let us say Intel is a one computer, one type of architecture, that is well known architecture, have the different instruction set. Motorola have the different instruction set. Means these two, we can say these two types of machines are different machines. They have the different instruction set is available, different kind of operations are available. So, I have to, if I am trying to solve a problem I devise a solution on based on the Intel machine that will not run on a Motorola machine. So that's the one thing. Another thing is these instruction set, not only in terms of their they have the different computers have the different instruction set, but they vary in terms of types as well, and as well as the complexity of the instruction. Some instructions may be simple instructions, some instruction may be complex instruction. You take example of simple and complex instruction. Say in 8086 architecture, 8086, that is Intel. In Intel there is an instruction which is called as a add instruction. It adds two numbers. So the typical instruction is, let us say, add, and then after that the two numbers can be given which we want to add it. A similar kind of instruction, but that instruction is a complex instruction, that is add v. V stand for a vector. This instruction adds 64 numbers from one list to the 64 numbers another list. So there we have the two list of numbers, 64 numbers each, and simultaneously this instruction can add 64 numbers in place of a single number. That is the normal add instruction which is available in 8086 architecture, and this add v instruction is available in a Cray computer. Cray computer is the supercomputer class of computer. So that is the difference between the simple instruction and the complex instruction, and type wise also varied from one architecture or from one machine, one type of machine to another type of machine. Some machine may have the subtract instruction is there, some may not have, or like that. Now this instruction set must be complete in such a way that any computation which we are going to solve, or any problem which we are going to solve, it should be expressed as a sequence of steps, and each step should be achieved by an instruction which is available in the instruction set. So each and every step of my solution of the problem for which I am looking a solution, each and every step should be expressed in terms of an instruction which is already available or defined in the instruction set of that particular computer. Now if I have, let us say, the machine is there, and in the machine the instruction set is also available. For each machine there is own instruction set is there. By using this instruction set I can write the solution for the problem or my computation problem which I want to solve it on the computer. I can devise the solution, and that solution. So for writing that solution I need some language in which I can instruct my computer to solve the problem. So that instruction set, say for example somebody asked you as to, so let us say, solution for some problem, you devise the solution, and you have to tell the solution to that fellow. How you will tell? Either you will tell verbally, you will speak in either English or any other language in which that person can understand. So this is important point. You have to tell the solution to computer in the language in which the computer can understand. So in what language you will write the solution of your problem such that the computer can solve it. So what is the native language of the computer? Then we know that computer is an electronic device made of the various electronic components like adders, subtractors, logic gates, and so on. All are the electronic device. Electronic device can understand only the two possible values. Either electronic component or a device can be switched on or switched off. So the state of an electronic device can have the two states, possible states. One is on and another is off. So all the information has to be represented in the computer in the form of 1 and 0. On, let us say 1, I am representing on as a 1 and off as a 0. So everything has to tell to the computer in the form of 1 and 0, and this is called as a native language of the computer, also called as a machine language. So to instruct the computer, I need to represent my steps, the solution steps, in the form of the instructions which is supported by the particular machine, and that instruction I have to write in the form of the machine language. Now you can visualize your program in terms of, or the solution of your problem, that is called as a program, in terms of a sequence of 1 and 0. So writing a program of the combination of 1 and 0 is tedious task. So the first drawback of this type of language, or programming in this type of language or in the machine language, is that it's a difficult to write the program or solution of your problem, particularly when your problem solution is very large. You have to write some hundreds of instructions, then it's very difficult to write program in this language. If any 0 becomes 1 or 1 becomes 0, your whole solution of the program will change and you will not get the desired output, and the chances are there. It's not a human readable, you can say, the form of program. Another drawback of such kind of programming is your program is not, maybe on one machine it is working, another machine same program will not work, because as I said that machine may have the different, each machine have the different architecture, so they have the different machine language. So same program cannot be written for that such that it works for all type of machines. So there is no standardization is available such that, okay, single machine level program can work for both of the, can work for the all type of machine. So the two drawbacks we understood from here. So what we need? A better language that user better in terms of the user, we can say user friendly. So in place of the long sequence of 1 and 0, let's say if we can define the computer operations, or we can represent the computer operations with the help of the mnemonic codes. Say for example, if I have to use a instruction which is called as a add instruction, which does the addition of the two numbers, in that case, in place of using some binary 0101 sequence for add operation, I can use something like that, ADD, and for subtract, let's say I can use SUB. It is more readable, someone can understand. Let's say add, something is written like that, add A comma B, it is understandable. Let's say it's an addition operation and trying to add two numbers which are represented with label A and label B. So A and B, you can say here I am representing two memory location in which these two numbers are stored. So it's a in a human readable format. Same thing, let's say the corresponding machine language is there, something like that. Let's say code for add is 0010. First memory location I am representing with something like that, and second memory I am representing with some 6-bit 5-bit combinations. So if you have these sort of lines in your program, 1010 sequence, now you can decide, you can see that which is more convenient way of writing the program. Still, what we need, if a program is represented with the help of, or you can say a instruction is represented with the help of the mnemonic codes like add, subtract, and the memory locations are represented with some label names, still this program has to convert into the corresponding machine language, because the machine or your computer can understand only that language. So what we need a program which is called as assembler. So we need a program, require a program which is called as a assembler that converts the assembly instruction into the corresponding machine instructions. Now, do you look any drawback of this kind of language? What we achieved actually here? Still my program is machine dependent, so I can say dependency is there, or I can say dependent, machine dependent. Program is machine dependent. One program which is running on one machine may or may not run, or run means may or may not give the correct result on the second machine or another machine, because assembly language is also called as a low level language only, or it is still on the machine dependent language. The only thing which we achieve from this assembly language is that now program is little bit more readable compared to the machine language, corresponding machine language. Here my program will be like that. My program will use something add, subtract, multiply, division, such kind of, you can say, mnemonic codes it will use. So readability is little bit improved, but still it is machine dependent, and that generalization is not possible, that okay, I wrote a one solution and that solution can work on, let's say, on Intel machine as well as on the Motorola machine or any different type of machine. So now we need, so these two languages are not appropriate for writing the programs, and still I can say if I are writing a large program, then again it is difficult to write that program with the help of assembly language. For a small program, some 10-15 instructions, it is fine, but if it's a huge program, thousands of instructions are there, then it's difficult to understand that program and maintain that particular program. So we need a language or a programming language such that it is more readable compared to these low level languages, machine language and assembly language, and along with that, the important thing is it should be a standardized programming solution. Means one program if you wrote, that should run on all type of machines. So you devise one solution, you wrote the program, and then it should work on all type of machines. It is not like that you have to write a different program for the same problem or for the different machines. If you are running on one machine type A, then a different program, machine type B, then the different program. So we need that kind of abstraction from the machine such that my program can be run on the any machine once I have that program, means that program I wrote for that particular problem. So for that, the third type of programming language, which is called as a high level language. The example of the high level languages is a C language, C++ language, Java language. These are all the high level languages. So what is the advantage of these high level languages? First of all, they are writing a program using these languages is more or like writing in the English kind of language. So is a better readability is there. And second thing is there, which is called as it's a program, your program can run on any kind of machine. If you have wrote a program for one machine, now it will work for any machine. So it has so again, because this machine can understand only the machine language, so you need here also you need a intermediate program that works between your program which you have written in a high level language program and the machine language program, that works an intermediate that converts your high level language program into the machine language, corresponding machine language program, and the name of that program is called as a compiler program. So this compiler program convert or translate your program, high level language written program, into the machine language, corresponding machine language. So now both the problems are solved in terms of the user friendly, because it's a English like a language. You are writing your program or program statements or step of your programs you are writing in terms of the English kind of language. And another thing is, it is a portable. One program which is written for one machine can run on any type of machine. The compiler program will take care of this conversion process. So is there any still drawback is there? The only drawback which is now it is there, that as it is, if you are trying to write a more optimized program in terms of that takes less memory, or it is optimized in terms of the resources which is used by the program in terms of processor power or the memory, that is not possible through the programming language compared to which is that the machine language or the lower level language make it possible to write an efficient programs. So if you don't understand right now this particular statement, don't worry about it. In later, once you move in the course, you will understand what does it mean by the writing the optimized program or more efficient programs. So now we understood that what is exactly my computer is there, what it can do, and how to solve the problem with the help of how means what I need to do. I need to write the problem solution steps in the language in which the computer can understand. We have the three languages, or broadly I can categorize two types of language. One is a low level language, another is a high level languages. In high level languages, like a lot of languages are there. Low level basically machine language and the assembly language is there. So now in this slide we will understand what are the basic steps to solve a problem. Let's say you have given one problem and you have to write the solution for these problems in the computer in terms of a program, and you have to get the output for that. So what steps you should follow? So first is to specify the problem requirement. First of all, you should know very clearly what is the requirement of the problem, what exactly I need to do it. So your problem statement should be unambiguous. If it is any ambiguity is there in the program, in your problem statement, you will not able to reach to the solution, or maybe you will get a incorrect solution. So unambiguous problem statement has to be defined first. Second step is to analyze the problem. In analysis phase, what exactly we need to do is, what is the input to the problem, what is the output of the problem, means what things my problem solution will take as an input from the user that needs to solve this, and then what will be the expected value which has to be either print or either it has to be display or whatever. Or is there any constraint to the solution of the problem? That also has to be here analyzed. Constraint means maybe let's say you have devised a solution, you says that okay, this solution is not applicable for the negative values. So that's a one constraint. Or maybe this solution have a restriction in terms of what is my range of the input value, or maybe the problem statement itself have the this constraint. Let's say you are trying to calculate the square root of a number, so the number should be a positive number. So that's the first constraint of your program. Third step is, once you analyze the problem, you identify your input, output, and any constraint if it is there, then you have to design the algorithm, and this is the most prominent or most critical step of your problem solution. Here what you are trying to do, you are trying to design your solution step by step. You are writing that this is step 1, step 2, step 3 and so on. Once you design your step by step solution, then you have to implement that step by step solution, and that step by step solution is usually called as an algorithm of the program. algorithm for the problem which is given to you. So, in implementation phase is each step you are representing in the instruction from the instruction set of your computer. As I said, each computer have the instruction set, and your problem solution steps, each problem solution step should have a corresponding instruction, at least one instruction should be there in the instruction set. So, now here it depends what language, in what language you are representing your solution, or you are in what language you are writing the solution of your program or solution of your problem, that is called as a program, machine language or assembly language or any high level language you are using. Whatever you are using, if you are using, let us say, high level language you are using. So, in this course, let us say we will use a C language to solve our problems. Then each step of your solution which you are written in terms of English kind of language, each step of your algorithm you have to convert into the corresponding the C programming statement. If you are writing the solution in assembly language, then you should know the assembly language of that particular machine, what is the available in the instruction set, and then the each step of your solution or algorithm you have to convert into the corresponding language. That is called as an implementation. And once you implement, then finally you have to test and verify the solution with some sample input. And the later step may come that you have to maybe after, let us say, you wrote a solution for some problem, and then later on solution problem is little bit modified, then you have to make some changes so that this modified statement, for the modified statement also this program works. Okay. So, that comes under the maintaining or updating the program. So, now let us take one example how to solve the problem. In that example, in this example we will use all these steps which I explained in the previous slide. So, problem, first of all, the problem statement that has to be given to the programmer. So, what is the problem statement here? Problem statement is to convert the currency value which is given in the dollars and to convert into the rupees and display the result. So, the problem statement is clear, no ambiguity is there. So, my next step is what? Analyze the problem. Analyze So, what analysis I have to do here before going to write the steps, solution steps or algorithm? I need to understand first what is input. So, what is input here? Input, I will get a value of currency value in dollars. So, I say currency value in dollars. This is my input. What is output? The currency value in rupees. So, it is a conversion. What I need for that? I need exchange rate. Exchange rate from dollar to rupees. $1 is how much rupees is there. So, that exchange rate is required. So, this problem is essentially converting from one currency value to another currency value. For that I definitely require the exchange rate. So, that is the only thing. Okay. Constraint, I can say something like that, the value, currency value cannot be negative, as well as 0 also. If the something is 0, then everything is 0 only. So, the value, currency value should be greater than or equals to 0. then only some fruitful result or the any value will come, currency value will come in the another currency from dollar to rupees. So if it is greater than equals to 0, then only, so I can say greater than 0 only, not equal to even. So some greater than, so value, currency value should be greater than 0. Currency value is greater than 0. That's the constraint is there. So analyze the problem. Okay. Then the next step is to design the steps. So for designing steps, design step means is essentially I am writing the algorithm. Simple, first step is read the input value, read the input value of dollar, input value in dollars. So I need some statement in whatever language I am writing the solution of this problem on my computer. I need a statement which can read a value from the user when this program is running on my computer. So reading a value, then second step is I need to calculate that corresponding rupee value of that dollar. So I say the rupee value equals to exchange rate, EXCHA exchange rate, I am writing complete, okay, multiply with the dollar value. Let's say user supplied some $50, then exchange rate is, let's say, 51.37 rupees per dollar. So dollar value multiply with this exchange value, then I will get the rupee value. Then finally display the result. And then I say stop. So this is my algorithm. Simple problem. 3 steps are there essentially: reading a dollar value, converting, for the conversion I need one additional information, exchange rate, multiply to the dollar value, and the display. So here I need essentially 3 instructions in whatever language in which I write the solution. So right now I am not talking about the particular language. One is reading, second is this, you can say the calculation steps. Essentially I am doing multiplication of the 2 numbers and storing the result into the third variable or third memory location, and third is the display the result. For output display I need one instruction here. So we will see this program how to write into the C language in the coming class. So now what is the advantage of, as I said initially when start this lecture, what is the advantage of this program converting and representing this into the instructions which my machine can understand? The advantage is now any number of values, dollar values can be provided, and this program will give me the corresponding value, rupee value for that dollar value. So I don't have to, let's say, manually every time I don't have to do, or I don't have to multiply the 2 numbers, exchange rate and dollar value, and getting this output this result for that. So I wrote one time my program, only one instance of this program, and then for the multiple thousands or millions of values I can dollar values I can convert into the rupee value. That is the advantage of the program. So that's all for the today's lecture. Thank you very much.